So a short video on the LG Therma V on how I managed to modify it and get cooling out of it. And I stress that this is definitely not something I recommend doing yourselves. Risk of warranty voiding and damage to heat pump, electrocution, other such things. But nevertheless, this is what I did. So first of all, just to explain, my heat pump is a HM091M U43. The first thing we need to do is be able to turn off the mains. And we want to get access into this panel here, and we'll need to do that by undoing the screws on the front and the screws on the side. I'll do that now, and then we can show you which dip switches you need to change. So with the cover off, please be careful, make sure the power is off because there's live 240 volts in here. So there's a circuit board. This is the circuit board here, and I don't know whether you can see, there's a set of dip switches here. These are the ones that we'll be adjusting. Now on my heat pump I have a third-party Tado thermostat, so it's currently switched over to only activate when that switch is on, so I have to deactivate that. And the other action is to be able to switch over the heat pump to have both heating and cooling mode, and I'll bring those up in a second. So the first thing I'm going to do is DP dip switch 8, which is the bottom one, switch it from the right to the left, which tells the heat pump that there is no thermostat installed, so it uses its own internal controller. The second one is dip switch 4, which I'm going to move from right to left, which says I'm on cooling mode. I'll try and put an image later so you can see the settings of that. So inside I have a domestic hot water tank and a buffer vessel at the bottom. I have two valves, so I have the main heating flow valve and the domestic hot water valve at the back. So to make it work, what I have to do is I have to manually override and open up the flow circuit because the signal. I then have to turn on the heat pump manually here, and I switch it over from auto to cool and set the flow temperature here. It also does not send a signal to the pump, so I've set and put on the pump a manual override to force the pump to flow at maximum flow rate. So the key thing here is to watch out for your flow temperatures and ensure that they do not go below the dew point, and you should be at least a couple of degrees above the dew point at the moment. So that will then start to cool down the inlet and outlet temperatures over a period of time. Something else I wanted to mention is because I bypassed the valves for the heating circuits, I need to turn off the hot water until I switch off the bypass to make sure that it doesn't try pumping hot water through it should be going to the domestic hot water tank into the flow circuit, so I just turn that off until such times I need it. Given it's the summer, only occasionally need to turn it on anyway. Something important to note is the standard radiator, you're just not going to get much cooling, if any at all, out of it. First of all, you'll probably have to remove either your TRV or your smart thermostat TRV because it will only flow when it thinks it's hot, and given the fact it's very hot, it's not going to flow. So you need to just disconnect that, and if your valves are the same, that they will just allow flow. A standard radiator, all that's going to happen is cold water is just going to run across the bottom. You might get a tiny amount of cooling. The best you can do is probably just stick a fan underneath and try and blow over the top to get a tiny amount of cooling out of it. So what I have found with these different radiators, I've installed these Yaga radiators that have got a fan in them, and you can control the fan to come on when it's hot or it's cold. These do provide a reasonable amount of cooling, and I can feel some decent cold air coming out of there. But again, don't forget to remove the TRV radiator so you actually get cold air, water flowing through them. So condensation is your biggest problem, certainly if you're running a bit close to the dew point here. So watch out. I've got a little bit of exposed pipework here right from the buffer vessel, where it's sort of the coldest at the moment, and I can feel on here there's a bit of condensation forming. So this is my spot to watch out for. If I'm getting too much condensation, I turn up the flow temperature. I'm lucky that my pipes that drop down and they go underneath the floorboards, and then underneath the floorboards are vented, and it just goes straight to ground in this 1970s house. So a little bit of condensation is not a problem, but do keep an eye on it. Radiators and other such things, and certainly any flow pipework that's in between floors, if it's not insulated, you're going to get quite a lot of condensation. So keep the flow temperature as high as you can. You're not going to get a huge amount of cooling, but it's really important to keep an eye on that. So you know it's working because you'll now feel the hot air that's coming out of here. I'd say it's sort of feeling about 35-40 degrees kind of thing that's coming out of there, and it's about 28-29 degrees, so it seems to work well. Generally ticks over, doesn't work too hard in cooling anyway, which is quite good if you've got open windows nearby. Okay, thanks.